Welcome back to Calculus with Mr. Walton. Today we're in Chapter 6, Section 3, and this is Antidifferentiation by Parts, where we're first going to look at our example 1. We're going to find the indefinite integral. So first, let's think about what could we do to better substitute so that this would look a little bit prettier. Take a moment, think about it. I think I want to get rid of that x squared, so I'm going to say let u be x squared, which means du dx is 2x, which means du is 2x dx, which means dx is du over 2x. So let's substitute. So I come back over and I get u times x e to the u times du over 2x. Nice! Look at that. Ka-chow. That my x's cancel. So now I have a beautiful u e to the u du, and I'm going to pull my 1/2 out front. Alright, so when I look at this, now we should be thinking about some ultraviolet voodoo. Yes, ultraviolet voodoo. Okay, so I'm going to say let my w be u, because I'm going to do w and v, and since I already have a u, and then I'm going to say that dw is equal to du. Awesome. And then I'm going to say my dv is equal to e to the u, which means that v is equal to e to the du is equal to e to the u. Alright, so now we use our ultraviolet voodoo, and we write VW, which is u e to the u, minus the integration of e to the u du. Alright, and then we're going to say, hey, I know what this is. This is u e to the u minus e to the u, okay, plus c. Now what we can't forget is our big 1/2. So it came down here and it's still a 1/2. It's still here because it's a 1/2. Now let's substitute in and get 1/2 e to the x squared, because I have a e to the u and an e to the u, times x squared minus 1 plus c. And hopefully that one makes a sense. I hope so. Yeah? Alright, let's look at example number 2. Find the indefinite integral for this one. Alright, you try it while I set it up. I'll give you a couple seconds, and then it's going to suddenly magically appear. Go. Alright, so we set up our u and our dv so that we can get a du and a v, and then hopefully we remember we're going to do ultraviolet voodoo, yeah? Hopefully. If not, this is a reminder. So let's practice. Let's plug this in. So my u, x squared, times my v, 1/3 e to the 3x, minus the integral of 1/3 e to the 3x times 2x dx. Awesome. Now what I need you guys to realize is if we rewrite this very nicely, 1/3 x squared e to the 3x minus 2/3 integral e to the 3x 2x dx. Oops, sorry, not 2x, but just x, because I pulled that 2 out. X dx, that we still need to do more ultraviolet voodoo right here. Alright, so this is again. So try it again, look this over, ready, go. Alright, so as we look at this, hopefully you notice that when we do this beautiful, lovely work again, that we see that our u is x, our dv is e to the 3x, then we have our du is dx, and our v is 1/3 e to the 3x. Then we substitute back in on this second half right here. Okay? And then I gave you the little short out to where I came up with the integral right here, highlighted in blue, so hopefully that matches up. And then final solution, we can just leave it as it is here in blue. And hopefully that makes sense. And let's look at our next example. All right, here we go. Example 3. Use tabular integration to find the antiderivative. So here is our example. Hopefully you guys remember that we're going to set up with our tabular integration. I'll let you get a head start. Try it out and go. All right, so we set it like this, and then let's look. Let's do all of our derivatives first. I think this is 3x squared, and then the derivative of that is 6x, and the derivative of that is 6, and then we have a 0. And then we're going to do our integration, and if we do that, we have negative 1/2 e to the negative 2x, and then we have positive 1/4 e to the negative 2x, and then we have negative 1/8 e to the negative 2x, and then we have 1/16 e to the negative 2x. All right. Now, please remember that we're going diagonally. All right, so we'll leave these two pieces alone. We're going to combine them for our final answer, and we need to simplify. So you try that real fast while I write out the answer. Don't forget your plus C. Don't forget your plus C. Don't forget about your switching of signs from positive to negative, but then we also have negatives where we would normally be adding. All right. And then we have a definite integral for our last example. So I'd like you guys to try this. Ready, set, and go. And hopefully you got something like this, because we've got some substitution, and then some ultraviolet voodoo substitution, and then some resubstitution so that we have everything back in terms of our x's, so that we can plug in pi and pi over 2, their square roots that is, and then we've got some trigonometry so that we can actually solve to get our answer of negative 1/2 minus pi over 4. This is a very extreme example of lots of things that could be done. Hopefully you can look it over and say, wow. If not, no wows there, you can say, Mr. Walton, show me how to do this again, and I'll see you another day. All right.